All right, pre-calculus. We are moving into graphing other functions such as tan, cotan, secant, and cosecant. In class, you guys have been complete rock stars. You've done awesome. So let's go ahead and move forward. Lesson 4.6 is graphs of other trig functions. And we are graphing, can you graph tan, cotan functions and secant and cosecant functions? The first thing I'm going to do is let's just write a reminder of the unit circle. So I am going to draw it right here. And remember at 0, 2 pi, this point is 1, 0. At pi over 2, this point is 0, 1. At pi, this point is negative 1, 0. And at 3 pi over 2, this point is 0, negative 1. So we're going to start by looking at the tan. Remember that tan is sine over cosine. So the tan at 0 and 2 pi is 0. The tan, well, sine over cosine gives me 0 in the denominator, so this will be undefined. The tan over here at pi is also going to be 0, 0 over negative 1. And then the tan at 3 pi over 2 is going to be undefined. So let's go ahead and take a look at how this is going to look. Remember that the tans were all undefined at anything over 2. And this is why we draw this vertical asymptote at anything over 2. Remember that all of the pi, 0, pi, 2 pi, all of those are going to be right at 0. So that's why we hit through 0. Now remember the unit circle is always brought into 4 different parts. So if I was to make this at 4 different parts, well, 45-degree angle, remember that tan is just going to be 1. So typically this just goes through 1. And then over here it would be negative 1 because remember it's root 2 over 2, root 2 over 2, and then it's negative root 2 over 2 and negative and positive root 2 over 2. So this is going to be kind of looking like a cubic. And it's going to pass through 1 at the quarter parts. Quarter parts. All right, so the book gives us a ton of information, so let's go ahead and take a look at the information. The period is just pi. So from negative pi over 2 to positive pi over 2, this period is just pi. All right, the domain is all real numbers except at every pi over 2. Now this gets kind of confusing. This is saying when x is pi over 2 plus any other pi, because remember that distance is pi. So at every pi over 2 plus 1 pi, 2 pi, 3 pi. Okay, the vertical asymptotes will also be at that pi over 2 plus n pi. And my range is from negative infinity to positive infinity. All right, so let's go ahead and now let's talk about the cotangent of everything. The cotangent, remember, is cosine over sine. So notice where the tan is undefined, the cotan, where the tan is 0, the cotan is undefined. Notice where the tan is undefined, the cotan, cosine over sine, is 0. So we are going to take a look to see what that looks like. So notice that at every 0, pi, 2 pi, 3 pi, we now have those vertical asymptotes. So vertical asymptote here, 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 here. And notice that this looks so similar to the tan, except it goes backwards. So it's going to go up on the left, down on the right. It will never go through the vertical asymptotes because at all those main pi over 2 points, 3 pi over 2 points, that is where it goes through 0. Remember at the quarters, again, it's going to go through 1. So we don't really have that marked here, but if I marked it, it would be 1 and negative 1. Okay, so the cotan is very similar to the tan. It's just shifted over between 0 and pi. All right, we're also going to look at the graphs of cosecant and secant. Remember that cosecant is the same thing as 1 over pi. Sorry, 1 over sine of x, not 1 over pi. So the first thing that we have to do is we have to graph sine. Remember, sine starts at 0, goes up to 1, down to 0, down to -1, up to 2. And I'm just going to go ahead and draw that backwards over here. Because at every cosecant, if we looked at that unit circle again, at pi, we would have a vertical asymptote. At 0, we would have a vertical asymptote. At 2 pi, we would have a vertical asymptote, and all the other pi's. Now, what am I talking about? Let me draw a mini unit circle. Remember, the sign is the y, so in this case, it's 0. In this case, it's 1. In this case, it's 0. In this case, it's -1. So what I'm saying here is that if this is over 1 and I flip it, remember this point is at 0 and 2 pi in every period thereafter, 4 pi, 6 pi. So when I flip it, this is going to be undefined. Same thing over here. When I flip this one, this is going to be undefined. Okay, this is 1 over 1. Well, when I flip that, it's still going to be 1, right? And when I flip -1, it's still going to be -1. So the other ones we don't have to worry about, the pi over 2 and the 3 pi over 2. So notice the cosecant, we're going to graph the sine. At all the zeros, we put vertical asymptotes, and I just love this because it makes it super easy. We draw these fun little parabolas off of the sine graph, but running right next to the vertical asymptotes. So that is what cosecant will look like. Not that hard. Now secant, remember, is 1 over cosine. So just like the sine, then we're going to graph the cosine. Well, remember the cosine starts here at 1, goes down to 0, -1, 0, 1. So this is the graph of the cosine. The vertical asymptotes are a little different this time because of what the cosine is. So remember, those are all going to be at the pi over 2's, 3 pi over 2, -pi over 2, 5 pi over 2, which really isn't there. And just like the cosecant with the sine, I'm going to graph the secant just like little parabolas off of the cosine. Notice they never go through the vertical asymptotes, they just graph right there. All right, great job. We're going to dig deeper into the next video, so I will try to get that filmed or videotaped for you.